So this problem is going to be about graphing from an equation, graphing sine or cosine from an equation. Now, I'll just write an equation here, being that of y equals 3 sine of theta over 3 minus 7 pi over 8, and then subtracting 2 in the end. So that is the formula we're going to be working with, and the basic equation looks something like this. Y equals A sine or cosine, I'll just use sine, B of theta minus or plus H, and then plus or minus K. And so we have A, we have K, but we do not have B or a simplified H or theta by itself, which are all things we need. So just from the data we have now, let's see what we can figure out over for our table. So we know that the amplitude will be 3, for that's what A is, it's just 3. Now what amplitude does is it takes our normal values, which is either 0, 1, or -1, and multiplies it by 3. So our values will end up being 3, 0, and -3. Now we also have vertical shift being that of -2, and so our whole graph will shift down 2. So what that does is it takes the 3 that we just got and it moves it down 2 spaces, so now it's at 1. Our 0 will be -2, and our -3 will be -5. Now our period, we find out period by having 2 pi, which is the normal period of the parent sine or cosine graph, and divide it by b, which we do not have yet. And that will give us our new period. And the phase shift is the opposite of h, and it has to be the simplified h, which we don't have. Now by opposite, what I mean by that is to remove it from where it is currently, we'd have to add it, which will make our negative be a positive, and if this was a positive number, we'd have to subtract it, making the positive actually negative. So what happens on the graph is, if it's a negative inside, it'll be positive shifting to the right outside, and positive inside is negative outside shifting to the left. So just to have that. Now let's find our b and simplified h. So we can see that theta seems to be multiplied by a third. So we would have our formula actually being 3 sine 1/3 theta minus, now we'd have to figure out what 7 pi over 8 dividing out 1/3 would actually be. Now we can look at it like more as the 3 being multiplied by the 7, because when you factor in the 1/3, it would be the only thing being affected would be the denominator. Now just to clarify, we have to do this to both sides, because when you take something out, when you factor out one value, you have to do it on both values inside the parentheses that one value is being factored out of. So that's what we have to do to the 7 pi 8, and that will give us a 21 pi over 8. Now it's 21 pi over 8 because if we multiply it 21 pi over 8 multiplied by a third, it still is 21 pi, but it's over 24, which simplifies to 7 pi over 8. Rather simple. Now that we have our b, we can figure out our period, which 2 pi divided by 1/3. And since we are dividing by a fraction, it is the same thing as multiplying by the reciprocal of that fraction, or multiplying by the flip of the fraction. So it would be 2 pi times 3 over 1, giving us a new period of 6 pi. So now we have both our new period and our phase shift, or in other terms, horizontal shift. So our new period is 6 pi, and our phase shift is right 21 pi over 8. So it's a positive. Now that we have these numbers, we can find out what our graph will actually appear to be. So for starters, we write down the 5 most important numbers of any sine or cosine graph, being that of 0, pi over 2, pi, 3 pi over 2, and 2 pi. So those are our normal theta values, which, before adding the amplitude or the vertical shift, for sine of theta, those values would be 0, 1, 0, -1, and 0. So now, what we do first is we would multiply by the, we would multiply by 3 to get rid of the 1/3. We divide out the 1/3, but it's really multiplying by a third. So we multiply all these answers by 3, giving us now 0 pi over 2, 3 pi over 2. And to make matters simpler for the future, I'm going to give all these a denominator of 2. So instead of being 3 pi, it would be 6 pi over 2, 9 pi over 2, and 12 pi over 2. So that's rather simple to think of, because 2 times 3 is 6, 6 times 2 is 12, so 12 pi over 2. And now what we do is we add the 21 pi over 8 to each of these. So let's change these again to what their value would be in eighths. So we multiply each of these by 3, giving us now values of, I'm sorry, we don't multiply by 3, we multiply by 4, of 12 pi over 8, 24 pi over 8, 36 pi over 8, and 40 and 48 pi over 8. I have to check something. Okay. Sorry it stopped recording, so I got a little worried there. It's fine. Yeah, this is going to be included into the website, but it will show a bit of how I am recording these videos and the rather strange setup I am using. Okay, so now that we have those values, we add or subtract a 21 pi over 8 to each of these, giving us 21 pi over 8, 33 pi over 8, 45 pi over 8, 57 pi over 8, and 69 pi over 8. So those numbers are kind of ridiculous to actually try and fit into this graph, which is only 6 backwards and 24 forwards, which I know from previous knowledge. I'm not going to count them out right now, that'd be a little ridiculous. So what we can do is we can add or subtract 2 pi from all of these. Now we can do that because on a unit circle, a full rotation is 2 pi. So 360 degrees is 2 pi. Now, what will happen is all these have their own values on the unit circle, and their value will be the exact same in a full rotation. So, say 21 pi over 8, somewhere over here. Now, yeah, just say it's randomly, it's not true at all, but say it's right here. I'm just having a random instance, for example. And now what happens is, you take one complete circle, and you end up in that same spot. So that's why we can do this, because a full rotation gives us the same answer, and it'll make our graph a little simpler. Now, 2 pi, to equal it for eighths, it would be equal to 16 pi over 8. So, since these are all rather large, we're going to subtract that from each. And so, I'll just rewrite those all right here. 21 pi over 8, 33 pi, 8, 45 pi over 8, 69 pi over 8. So now we're going to subtract 16 pi over 8 from each of these, giving us new values of 5 pi over 8, 17 pi over 8, 29 pi over 8, 41 pi over 8, and 53 pi over 8. Now, those numbers are still kind of ridiculous, so I think I am going to subtract another 16 pi over 8, and stated from earlier, it's the same, except for going one loop, you're now going 2 full loops. So you still have the same value in the end. So what it will now be is negative 11 pi over 8, pi over 8, 13 pi over 8, 25 pi over 8, as shown, and 37 pi over 8. Now, before continuing any further, I just want to make sure this is all seen on my camera. It's in a rather weird spot, so I have no idea if this has all been recorded or not. I hope it has. But, so that's so you can see all the work. Now let's continue. So now that we have these numbers, they're more reasonable to deal with. We can now figure out our horizontal scale. So, judging from how this is, looks like it'd be simple to do that every dash is 2 pi over 8, or a fourth of pi. So we'd start at negative 11, which would be right here, being negative 11 pi over 8, 1, so just pi over 8. $13 pi over 8, $25 pi over 8, and 37 pi over 8. Now, let's go back to these sign values. So those still need to be all multiplied by 3 giving us still 0, 3, 0, -3, and 0. And from those answers, we subtracted 2. I explained why we do this earlier, because k just is simply subtracted. You vertically shift downwards twice, just reiterating. And so it'd be -2, 1, -2, -5, and -2. So -2 is our midway point. Since these numbers are decently spaced and we don't have that many spaces up and down, I'm just going to say every dash is 1. So 1, -2, and -5. That gives us that. So now we can graph out what this will look like. And that is our finished product. That is what this equation will look like graphed on paper. Yeah, nothing much else to that. I'm just going to make sure that this is caught on camera again. And yeah, good.